Hi everyone, welcome to 4.1 Day 3. We're still going to be working with chain rule. The first couple examples are going to be applications of this, really just writing slopes of tangent lines, and now we just have to differentiate functions requiring the chain rule, and then we'll do some more practice with combining chain rule with our product and quotient rules. So just again getting a little deeper into problems that would require the chain rule. So the first one asks us to find the slope of the tangent to the curve, and now we have y equals sine of x to the fifth power at the point where x equals pi over 3. So we know if we're going to find the slope of the tangent line, the first thing is we have to find the derivative. That's going to give us the slope of our tangent line. So I have y prime, and now remember, sine to the fifth power of x is really the same as sine of x to the fifth. And if you write it that way, then it's easy to see that we have a function to the fifth power for our outside, and sine x is now our inside function. So if I differentiate this, I'm sorry, this was y, not y prime. So now if I differentiate, the first thing I'm going to take care of is my power rule. And remember, our inside is going to stay the same, so I'm 5 times sine of x to the fourth power. And then I'm going to multiply by the derivative of sine x, which is cosine of x. So I'm not going to worry about simplifying that. I know I need to find the slope of the tangent at the point where x equals pi over 3. So now I'm going to go ahead and plug in pi over 3. Right? We know we're doing this to find the slope of the tangent. So y prime of pi over 3, we're going to have 5 times sine of pi over 3 to the fourth power times the cosine of pi over 3. And so now substituting, I know sine pi over 3 is root 3 over 2. And if you're finding you can't do these values in your head, you're going to want to go back and review your unit circle. This would easily be a no calculator question. So that's to the fourth power, and then I have cosine pi over 3, which is just 1/2. So now if we do some simplification, root 3 to the fourth power is going to give us 9. And 2 to the fourth is 16 times our 1/2. So now if I multiply, I'm going to get 45 over 32. So that's the slope of our tangent line. And I guess actually this did not want an equation. All we needed was the slope, so we are done once we've found that. Now the second question is still dealing with slopes of tangent lines, but has a little different spin on it, and this could certainly be an AP type question. And so what this is saying is it wants us to show that the slope of every line tangent to this curve is positive. So in other words, what we need to do is show that y prime is always positive. So in order to kind of work that out, the first thing we're going to do is, again, just find our derivative. Okay, so now I could use y prime or dy dx, and that's just different notation for referencing that derivative. Now, when I look at my function, I could use quotient rule to find this derivative, but actually I'm going to back up for a minute. I'm going to go back to my function y. Hopefully, I'm going to recognize that 1 minus 2x to the third power is the same as the function 1 minus 2x to the negative third power. And so now I can avoid that quotient rule. Okay, so now I have a chain rule problem. Okay, I'm going to do my power rule first. So I have negative 3 times 1 minus 2x to the negative fourth power. And then I'm going to multiply by the derivative of my inside function, which is negative 2. So if I simplify, I'm going to combine here, multiply my negative 3 times my negative 2. That's going to give me a positive 6 times 1 minus 2x to the negative 4th. And if I rewrite that with positive exponents, I have 6 over 1 minus 2x to the 4th power. And that is my derivative. So now, if we think of our original question, right, it asks us to show that the slope of every line tangent to this curve is going to be positive. And so if I'm looking at my slope here, my numerator I know is always going to be positive, because a positive 6 is constant. And down here, because my power is to the 4th power, no matter what I have in parentheses when I take it to the 4th power, that has to be positive as well. So since my derivative, since y prime, is going to be the quotient of two positive numbers, make sure you can see this. I'm going to scoot it up a bit. Since y prime is the quotient of two positive numbers, then my slope is always going to be positive. So we didn't need to plug any values in there. We just had to do an analysis of that derivative function. Okay, so those two examples were more of our application type examples. So now we're going to look at just more kind of mechanical examples of how we use chain rule along with product and quotient rule. So on the next page, first one we have here is a product rule problem. Right, my first factor is the square root, and I'm multiplying by this second factor here. And so the first thing I'm going to do is rewrite that first factor with a rational exponent, so it's a little easier maybe to work with. And then there's my second factor. So here we go, dy dx. I'm going to take my first factor as is, so negative 3x cubed minus 4 to the 1/2 power, and I'm going to multiply that by the derivative of my second factor. So times negative 4x cubed, and then I'm going to add my second factor as is, and I'm going to multiply that times the derivative of my first factor. So I'm going to have times 1/2. Now here with my first factor, hopefully you're recognizing that this is going to require the chain rule. The first thing I'm going to do is deal with my power rule. So 1/2 times negative 3x cubed minus 4 to the negative 1/2. And then I need to multiply by the derivative of the inside, which is going to give me a negative 9x squared. And so if we've gotten through that, you have all the pieces. We're just going to see if there's any simplification that we can do to make this a little easier to read. So the only thing I can really do here is I'm going to pull this negative 4x cubed out front. There's nothing I can distribute. So that's my first term. Now my second term, I notice since I'm multiplying by a negative here, I'm going to have minus. I'm going to have a 9x squared in the numerator. I have a negative x to the 4th minus 1 term in the numerator. In my denominator, I'm going to take the 2 from my 1/2, and then I'm going to move this down to make it a positive exponent. So I have times a negative 3x cubed minus 4 to the 1/2. And that's really as far as we're going to go with our simplification. Again, for right now, we're just focused on keeping track of all the pieces that we've used our chain and our product rule correctly. And so for the purposes of today, I'm just going to do this one example, and then we'll do number 2 in class, just to kind of touch base and make sure everyone's clear with what's happening here. So we'll skip 2 for now. We're going to go on to number 3, which is our quotient rule combined with chain rule. So we're going to start off with quotient rule, which we know is low, negative x squared minus 4 to the negative 5th. D high, so the derivative of my numerator, so I'm going to multiply by 3x squared. Minus our high, our numerator, x cubed plus 5. D low, so times the derivative of our denominator, and here again we're going to run into our chain rule. We have an outer function, x to the negative 5th, and an inner function, negative x squared minus 4. So we're going to deal with our outer function first, so I have times negative 5 times negative x squared minus 4 to the negative 6th power. And now I'm going to differentiate the inside, so I'm going to multiply by a negative 2x. And then we know that is all over our low squared, so negative x squared minus 4 to the negative 5th, and we square that function. So again, here we have all the pieces that we need, and we just want to see if we can do any simplification, and very basic simplification. Tomorrow when we do some more practice, we'll do some more extensive simplification and work with some multiple choice practice. So for this problem here, my first kind of term of my numerator, all I'm going to do is pull that 3x squared out front. Now I'm going to see if there's anything I can kind of maybe multiply to simplify my second term a bit. And so the only thing I see here is taking my negative 5, if I can find another color here. I'm going to take my negative 5 and my negative 2x, and I'm going to go ahead and multiply those together. So negative 5 times negative 2x is going to give me a positive 10x. Since I have subtraction here, it's going to be minus 10x. And then I'm just going to write down my other factors, my x cubed plus 5, and my negative x squared minus 4 to the negative 6. Now down here I have a power to a power, so I'm going to multiply those and make my denominator negative x squared minus 4 to the negative 10th power. Now we could go further with this and distribute the 10x, but for right now, like I said, I'm just more concerned about making sure we have all the necessary pieces in our solution, and I'm not as worried about simplifying. So we'll leave our answer as it is. So tomorrow when we come into class, before I set you loose on some multiple choice practice, we'll go through number 2 and 4 and answer any questions that you have, and then you'll have time to practice. See you tomorrow.